Hello, all. Welcome to the States of Matter and Phase Changes podcast. Um, first, we're going to start discussing the states of matter. So, hopefully, you know how many states of matter there are, but if you don't, you'll know by the end. All right, the three main states that we all know about are solids, liquids, and gas. All right, solids are very close together. They vibrate when they're in place. They have low kinetic energy, definite volume, and a definite shape. Okay, so they stay the same shape and the molecules don't magically spread apart more than they already are. Okay, liquids. Liquids tend to be able to slide past one another. They have medium kinetic energy. Um, they have a fixed volume, so you don't, have 20 ounces of Coke and then, magically one day you wake up and you have 30 ounces of Coke in there, okay? So they have a fixed volume, um, but they take the shape of their containers, so they have a variable shape. Gases, the last state of matter that should be familiar to you, they are very fast moving. They bounce all around the place, off each other, off the walls. They have very high kinetic energy. Um, they do not have a defined shape. They take the shape of their container, which is why we have a lid on the container over here. And they also have a variable volume. So if you were to open this container, the gas molecules would spread all out everywhere. Okay, so they don't just stay in one place like solids and liquids do. All right. Fourth state of matter that you've probably heard about is plasma. Plasma has very high kinetic energy, and what happens is the particles collide so fast, they're going so fast, and then they collide, and you have enough energy provided during that collision for it to break the actual molecules, and so you actually end up with like waves of positives and waves of negatives. They are gas-like, so that means they have a variable shape and a variable volume. So they take the shape of the container that they're in, and they also can expand and have a different volume. Some common examples are stars, fluorescent light bulbs, lightning, and plasma actually happens to be the most common state of matter on Earth. All right, the fifth state of matter is one you've probably not heard of yet. Maybe you have. It's called the Bose-Einstein condensate. It's not completely understood at this point. We do know, though, that it exists at a specific temperature called absolute zero. And at absolute zero, the molecules get so very cold, if you will. There's so little kinetic energy. The molecules actually stop moving. They're not vibrating. They're not sliding past one another. They are stationary. And they kind of collapse into one another, form a big blob, and then that is been coined as a superatom. Okay, so it's a really cool state of matter. Not all elements or compounds can obtain this state of matter, though, so it is kind of special. All right, absolute zero. Well, we saw that Bose-Einstein's condensate exists at absolute zero. And absolute zero is a theoretical temperature at which there is absolutely no molecular motion. It exists at 0 Kelvin. Kelvin is the temperature scale, is the temperature scale that we use in science commonly. And here you see absolute zero over here on our little Kelvin one, which is about negative 273 Celsius, which is actually negative 459 degrees Fahrenheit. So it's super, super, super cold. All right, and finally, to top off phase changes. So the states of matter, there are different states of matter. We talk about the three common ones the most, so the solid, liquid, and gas. And when you talk about them going from liquid to solid or from solid to liquid, there's a specific name that we give that phase change. They all have specific names. Here's the list of the names. You're probably familiar with all of these except for deposition and sublimation. Deposition is gas to solid, so this would be like snow that forms in the clouds. Okay, so in the clouds you have gas, water molecules that are in gaseous form, and then they actually condense straight to snow. Um, Sublimation is the opposite. It is going from a solid straight to a gas. You've probably seen this before with dry ice. So if you've ever played with dry ice, it's a big chunk, and then you put it on the table, and then all of a sudden it just starts smoking and steaming. So it's going straight from a solid to a gas. The other four transitions you should be pretty familiar with. Melting is solid to liquid. Freezing is liquid to solid. And vaporization is liquid to gas, and condensation is gas to liquid. Now, each of these processes are either endothermic or exothermic. Endothermic means that energy is, well, snap, crackle, pop. This is backwards. Let's go ahead and fix it while you're all just sitting here watching me. All right, so endothermic is when energy is absorbed, and exothermic is when energy is released. Okay, so during an endothermic process, we take in energy for the process to occur, and during an exothermic process, energy is released from it. Okay, that energy could be released in the form of heat, light. Okay, so there's different forms of energy that it could be released in. So now I want you to do a little thinking before tomorrow's class. I want you to label each of the phase changes on the previous slide as either endothermic or exothermic, and we'll go over these tomorrow. Okay, so these 6 phase changes, tell me if you think it's endothermic or exothermic. You may want to think about what the kinetic energy of liquid is compared to gas, and if you had to get more to get there or get less. That's the only hint I'm giving you, though.